Great morning, students. How are you all doing? Today, we are going to look at a topic in chemistry, which is relative vapor density. Relative vapor density. So before we proceed, get your writing materials ready. Your notes, your biro, and your calculator. Now, in this topic, we have two objectives we are going to achieve. Two objectives. One is that after this class, you should be able to state the relative vapor density. Then second, you should be able to calculate problems that are related to this topic. These are the two objectives. Are you with me? Now, let's go. The vapor density of a gas is the number of times a given volume of gas is heavier than the same volume of hydrogen at a constant temperature and pressure. That is the law of relative vapor density. I'll say it again. Make sure you're writing. The vapor density of a gas is the number of times a given volume of gas is heavier than the same volume of hydrogen at a constant temperature and pressure. And we have formulas for this vapor density. One of the formula is mass of one molecule of a gas or vapor at STP over mass of one molecule of hydrogen. Remember that hydrogen is a diatomic gas. Or we can use mass of one molecule of a gas or vapor at STP over mass of two atoms of hydrogen. Or we can also use mass of a given volume of any gas over mass of equal volume of hydrogen. These are the formulas for relative vapor density. So when a question is given to you, you should be able to determine which formula will suit the question. Okay? Are you with me? Now, let's continue. Calculations involving relative vapor density. The calculations. One says, calculate the vapor densities of the following gases from the data given. A. 560 centimeter cube of oxygen at STP weighs 0.8 grams. You are asked to find the vapor density when 560 centimeter cube of oxygen at STP weighs 0.8 grams. Remember the formula. In this particular case, we have mass. So we are going to use that formula that has to do with mass. But before using the formula, look at the solution first. For A, you are going to find the mass of hydrogen when it weighs 560. This mass given to you in that question for A is when the oxygen weighs 560. The mass is 0.8 grams. So you are going to find the mass of hydrogen when it also weighs 560. Because if you go to the formula of vapor density, we have mass of that gas over mass of equal volume of hydrogen. Are you with me? So, from what we have, 1000 centimeter cube of hydrogen gas will weigh 0.09 grams, which everybody knows. Then, that 560 of hydrogen will now weigh what? If less, more divide. You multiply 560 by 0.09 divided by 1000. Punch in your calculator, you have 0.05 grams. That is the mass of hydrogen when the volume is the same as oxygen, which is 560. Having known that, you now apply the formula to get the vapor density, which is mass of a given volume of that oxygen over mass of equal volume of hydrogen. Mass of that oxygen is 0.8 over mass of the hydrogen, which we have calculated 0.05. Punch your calculator, you have 16. There is no unit. Hope you're writing. That is for number 1. Let's look at the next one. For number B, you do the same thing. 1000 of hydrogen will weigh 0.09, then 1400, because that is what we have in the number B, the volume. 1400 centimeter cube of hydrogen will now weigh what if let's modify it? We have 0.126 grams. We now apply the formula for vapor density, which is mass of that substance over mass of equal volume of hydrogen. The mass of the substance we are talking about here is the one given to us in the question, 4.0, over the mass of the hydrogen we have calculated, 0.126. If you punch your calc, you have 31.74, no unit, because we are dealing with mass. Are you with me? Let's look at the second one. An evacuated flask, listen up. An evacuated flask weighed 30.50 grams when filled with dry hydrogen. It weighed 30.50 grams when filled with what? Dry hydrogen. And 39.82 grams when filled with dry chlorine at STP. When empty, the flask weighs 30.23 grams. The question says, calculate the relative molecular mass of chlorine. We are not looking for vapor density here, but before you can get the relative molecular mass of chlorine, you must first of all get the relative vapor density. Yeah, that is it. So if you look at this question, mass of dry hydrogen, for you to get mass of dry hydrogen, you have to subtract the mass of the flask with hydrogen. Mass of the flask with hydrogen is 30.50. Then the mass of the empty flask is 30.20. If you subtract both of them, you have 0.27. The mass of dry chlorine only is the same as mass of the flask with chlorine minus mass of the empty flask. You now get the mass of only chlorine, which is 9.59 grams. Now, apply the formula to find for vapor density, which is, when you're looking for vapor density of chlorine, remember, so we have mass of chlorine over mass of equal volume of hydrogen. Mass of chlorine that we have gotten is 9.59. Mass of hydrogen is what? 0.27. You divide, you have 35.5. Now, relative molecular mass of that substance is vapor density times 2. If you multiply vapor density by 2, you have the relative molecular mass, which is 71. Are you with me? That is all. Very simple something. Now do this. State relative vapor density. Then calculate these questions that follow. You're submitting them on Tuesday. Unfailingly. On Tuesday. Make your research. Solve them. Submit on Tuesday.